Yes. After that performance, you will realize that I2 out of I1, what will it become? Remember, I2 was A epsilon V F out of D. When you divide by I1, I multiply by the reciprocal, which is D out of A epsilon naught VF. This D will cancel, this A will cancel, V will cancel, and F will cancel. So we shall begin with I2 out of I1 as epsilon out of epsilon naught. And remember, this is the dielectric constant. Therefore, we can always have this one equal to that the I2 out of I1. That is what we and the relative permittivity has no units. Okay? The relative permittivity has no units. We want to do a calculation. In a few minutes. So you can write that the plates of a parallel plate capacitor are each of area 0.16 meters squared. That the plates of a parallel plate capacitor are each of area 0.16 meters squared. Okay? And are separated by 10 power negative 3 meters. That is D. And are separated by 10 power negative 3 meters. And the space between them is filled with a medium of relative permittivity 5. A space is filled with a medium of relative permittivity 5, full stop. The vibrating contact with frequency of 50 per second. Frequency 50 per second. The vibrating contact with frequency 50 per second repeatedly connects the capacitor across 120 V battery. Across 120 V battery, and then discharges it through a galvanometer whose resistance is of order 50 ohms, and then discharges it through the galvanometer whose resistance is of order 50 ohms. Calculate the current recorded by the galvanometer, and we are told that use epsilon naught as 8.85 exponent negative 12. Use epsilon naught here. Okay, so the information is very clear. We have a capacitor which is being charged. We have the V source, then we have a resistor here, and then we have a galvanometer here that records. So we are told that area is this. This distance between the capacitor plates is given, that D. Then they say they have pressed a dielectric here of constant 5. This is 120 volts and etc. What do we know? What we know is that when this one is charging, the capacitor is charging it, the current I is 2F. We have seen that one before. The charge is CV, which is CVF, okay? But C is, for a parallel plate capacitor, is A epsilon out of D. So we have the V and we have the F. But our information, we are not given the permittivity of that medium. We are only given its relative permittivity. But from the definition of relative permittivity is the permittivity of the medium, permittivity of air. Meaning, if I want this one I can cross multiply this one, I multiply it here, and therefore the permittivity will be epsilon r, epsilon naught. Okay? Therefore, my current I will be, I substitute A, permittivity, epsilon r, epsilon naught, then V, then F out of D. I think I have all this information. So this becomes A 0.16, epsilon R 5, epsilon naught 8.85 exponent negative 12, and V 120, F 50, then separation D 10 exponent negative 10 exponent negative 3. So when you substitute there, what does your calculator give you? In amperes. What does your calculator give you? Please give us the value. We are back. We are back, and we are ensuring continuity of learning amidst all challenges. And we are ensuring that you remain healthy and safe. Remember the two, the HIV and the COVID, they both kill. You have to stay safe, avoid them. The password, social distance. Keep a distance. Don't be close to someone. You don't need those other methods if you are not close to them. Keep a distance. Meanwhile, you should have got the answer. What is your value? Thank you very much for getting that value. If you have the same as mine, then we can celebrate together. If it is different, you can check your calculator again. I have 4.248 exponent negative. What do you have? I have this, you have that. We can work together. I'm Teacher Kos of Back Science Education Consultants. Thank you for studying with us. Thank you for attending our lessons. I pray that may God bless you and bless you and bless you for attending these lessons. And I pray that may you understand all this. So next, we shall see the action of a dielectric. We shall see the effectiveness of capacitors, depending on the arrangement, series, parallel. Then we shall see many calculations as we wind up this. And I pray that may you understand this chapter of capacitors 100%. Only found at Back Science Education Consultants. I'm Teacher Kos. One of our contacts is here. Feel free to contact us in any way possible for any academic query, for any academic related issue. Thank you very much. Please remember that you have to be alive and you have to stay safe. Thank you for loving us. We love you too.